Butter made from carbon dioxide and vanilla made from plastic trash? Researchers are exploring ways to transform different waste substances into various food products. For the first time, an artificial butter has been created from carbon dioxide by the California-based startup Savor. This approach doesn't involve livestock or crops, potentially offering an alternative to traditional butter sources. The company suggests this method could have a reduced environmental impact compared to dairy or plant-based alternatives, potentially decreasing greenhouse gas emissions and land use. Savor claims its product closely mirrors the taste and function of dairy butter and has secured financial support from investors, notably Bill Gates. Savor's technology is still developing, with the company aiming to expand into other food products like milk and cheese. However, challenges remain, including scaling up production and lowering costs to ensure wider accessibility. While the technology presents a potential solution, its long-term impact and acceptance within the food industry are yet to be determined. The company suggests its process combines CO2 extracted from the air with hydrogen from water and then using heat to create chains that are mixed with oxygen to produce synthetic fats. These fats are said to closely resemble the taste and functional properties of dairy butter. Beta-carotene is added to achieve the familiar yellowish hue of traditional butter. Savor highlights several potential environmental benefits, stating that their process doesn't release greenhouse gases, requires no farmland, and uses significantly less water than traditional agriculture. However, independent verification of these claims is needed to fully assess the product's environmental impact. Like many emerging food technologies, Savor faces the challenge of reducing costs to make its products affordable and accessible to a wider consumer base. This step is crucial for achieving a substantial environmental impact. In another project, researchers revealed that plastic bottles can be converted into vanilla flavoring using genetically engineered bacteria. The researchers used genetically engineered E. coli bacteria to turn plastic waste into a chemical additive known as vanillin, which is used in food, cosmetics, and other products. Researchers initially broke down plastic bottles into terephthalic acid using enzymes. They then transformed terephthalic acid into vanillin by mixing it with engineered E. coli at 98.6 degrees Fahrenheit. With the help of bacteria, they achieved a 79% conversion rate. The research opens up new possibilities in green chemistry, showing a promising way to repurpose plastic waste into valuable substances, although it's not yet confirmed if the resulting vanillin is safe for consumption. More studies are needed to refine this method and scale it up for larger plastic quantities. This innovation not only addresses the growing vanillin demand, but also presents a new approach to reducing plastic waste and contributing positively to the circular economy. Other research unveiled the remarkable ability of mealworms and superworms to consume and degrade plastic. Mealworms can safely ingest various forms of plastic, including toxic additives in polystyrene, without any adverse effects, making them yet another viable option for reducing plastic waste and recycling it into protein-rich feedstock for other animals. The degradation of plastic by superworms is facilitated by specific bacteria in their guts, particularly a strain of Pseudomonas aeruginosa that uses an enzyme called serine hydrolase to break down the plastic. The quest to convert waste into food shows a growing momentum in the pursuit of sustainable solutions within the food and waste management sectors. As these technologies inch closer to becoming a reality, questions surrounding their safety and consumer acceptance remain to be answered. While the potential benefits are undeniable, it remains to be seen how the public will react to consuming foods derived from carbon dioxide or plastic waste.